All right, we are back. My name is Seth Juarez. This is Channel 9 Live, coming to you from the Seattle Convention Center for Build 2017 edition. I've got a special guest, and I'll let you know. We had Scott Guthrie on. First thing, everyone wanted to know all about this. So hopefully you'll have some good stuff to show us. I'm excited you brought your computer to show some demos. Why don't you introduce yourself to us? Tell us who you are and what you do.
Sure. My name is Shyam Nair. Truly excited to be here today because we announced Azure CosmosDB, and I run program management and product management for Azure CosmosDB.
So tell me about CosmosDB. What is it? Why is it important? What should people know about it right away?
Yes, Scott talked about in the keynote this morning, as Microsoft was going through the transition from an enterprise software to more a cloud services company. In 2010, we started a project called Project Florence. The basic idea was, what are the pain points that internal large-scale, internet-scale applications were having? How could we actually solve that using a globally distributed database? So Project Florence took that effort on in terms of building a database that was truly globally distributed from the ground up, provided the low latency capabilities for a global scale application or a service, and making sure that not only the pain points that we were seeing as internet scale application, but our customers as they were moving to the cloud could actually benefit from it.
Right.
In 2015, we released Azure DocumentDB, which was the first iteration of it in terms of the same technology. But since then, we have been continuously working on it, making sure a lot more capabilities are built in terms of the query performance improvements, in terms of multiple models and multi-APIs that we can support on top of it, and making sure that horizontally scale and partition across the globe.
Right.
And today, we're excited to actually make sure that all of that is available to the external customers in the form of Azure CosmosDB.
So is Azure CosmosDB the evolution of DocumentDB? Is it now it's CosmosDB and not DocumentDB? Are they two separate offerings? Tell me about that.
No, it is a single offering. DocumentDB APIs, which is both SQL and JavaScript APIs, are supported in Azure CosmosDB. A lot of innovation has gone in over the years in terms of the multiple models we support, the multiple APIs we can support, as well as the overall service itself. That I just don't want to say an evolution and think about this as just a next clip stop. It's actually a large journey that we have undertaken, and with a lot of customers, both external customers, a lot of retail customers, IoT customers using us, as well as internal services, large-scale Microsoft Cloud services actually leveraging us. So DocumentDB was a click stop in terms of our journey, and CosmosDB is, we continue to innovate on it, but CosmosDB is truly bringing that all of those capabilities out to the external customers today.
So for those that are using DocumentDB, they're moving forward to CosmosDB. Is that what's happening?
That's correct. So for those who are using DocumentDB today, they can continue to use the DocumentDB APIs, JavaScript or SQL. They get a whole lot more benefits in terms of the true capabilities we supported in terms of newer APIs is available to them. We actually, behind the scenes, and I don't think anybody noticed that, they will notice as they run their applications, behind the scenes, improved the query performance and the amount of resource units or request units that are required in terms of running a workload. So a lot more innovations have gone in, but it'll be seamless, and they'll find it that their apps will continue to work, no changes, but with more capabilities now.
So if you're already using DocumentDB, you literally don't have to change anything when you're using CosmosDB.
That's correct.
The other thing that I heard, and this was surprising to me, and maybe you can speak to it, is that if you use MongoDB and you switch over to into CosmosDB, you're still good.
That's right. So one of the views we have had is MongoDB has a lot of good mind share among customers, but a lot of application challenges, especially when you're really thinking about running a global scale-out application using a database. So our view is, if you're familiar with Mongo, if you use the Mongo framework, say you're using IDEs like Mongo Chef or from 3T or RoboMongo, continue using that. Use a framework that you're familiar with. Just treat CosmosDB as your secure Mongo instance. You get all the benefits of CosmosDB, including the global scale-out, the low latency capabilities that we talk about, the multi-models, whether you want to run graph queries on top of it. You get all of that, and you still look and feel in terms of how your applications are. It's lift and shift of Mongo applications.
So is it as easy as changing the connection string on your Ruby on Rails app to CosmosDB? Is it really that simple? And then moving your data over?
Yeah, so we have samples where we talk about how you can change the connection string of your RoboMongo instance or a Mongo Chef and directly talk to us as a Mongo instance. Yeah, it is as easy as that. We actually have a globally scaled Mongo application running end-to-end. Behind the scenes, it's CosmosDB.
Wow, that's amazing. So I come from old school relational theory, SQL queries, and the first time I heard about document databases, I was affrighted, right? Well, what about referential integrity and what about, but I've since moved away from that. Can you help me understand when is a good time to use something like CosmosDB versus something that you traditionally would do in a relational database? This is something that I always had a hard time with. Maybe you can help me.
Yeah, I think there are some key capabilities in terms of a database like CosmosDB. Especially look at applications today which are globally distributed. Your user base is globally distributed. You have users in US, you have users in Australia, Japan, and you really want low latency capabilities. Everybody is expecting fast, responsive access to their applications, right?
Right.
So you want to delight your users, and you really want your database as close as is to the user. It's really hard to do that with current commercial database.
Right.
With Azure Cosmos DB, what you get is a couple of things. One, you can just set any one database account associated with any number of Azure regions. We are what we call as a ring zero database, or a foundational service of Azure. A lot of the Azure services that are built on are taking dependency on Azure Cosmos DB. So you could have one database account, and your data is replicated across the globe. Your application instances can now read from your local regions. So you read from your local regions, you get millisecond latency access in terms of single millisecond latency access.
And that's in the SLA though, the latency of calls. Read, write, in the SLA it says we guarantee it will be this fast.
We actually guarantee you that we have a comprehensive SLA. It's only one of the only services that has that in terms of availability, uptime, everybody provides. For performance or latency, we provide at a P99 of your queries. We'll make sure that you get the single millisecond latency. We also want to make sure that the developers are not worried about correctness of data, durability of data. So we provide multiple consistency levels that they can actually choose, and we provide SLAs backing that, as well as the throughput that you want to set in terms of what your application needs.
So because I remember when I was studying partitioning on, for example, MongoDBs and sharding and such. Are you saying that with Azure Cosmos DB, that's something that just happens? Do I have to set like a partition key? I mean, I'm trying to understand here.
Yeah, as a developer, yes, the one thing you have to do is choose the partition key.
Of course. Right? Okay, so it can't be that magical, which is good, because you're making me nervous here.
Yeah. So beyond that, it's horizontally partitioned transparently. Based on the partition key, as your data grows, we'll horizontally partition. This horizontal partition works across the globe. As well as in terms of throughput, we'll distribute the throughput. You can set the throughput that you need, and you will only pay for the storage that you use and the throughput that you actually need.
I see. So you're not paying for, like, here you have this database, you're renting it. You're paying for just what you're using in terms of data and compute. Is that right?
What you're using in terms of the storage, and what you think you will need in terms of what you provision as your compute. Yes.
I see. So we've talked a lot about Cosmos DB. I was hoping you could show us something a little bit, if that's okay.
I'll just do it on the portal.
All right, let's cut to his computer here.
It's easy. Just to, if you want to start creating a Cosmos DB, come in here, just say I have a couple of them in my demo account. I click add. The benefit here is, you can see here, if you are familiar with Gremlin and you want to interact with Cosmos DB using Gremlin SQL, you can just do that. You want MongoDB. If you're a lift and shift of MongoDB application, you choose that API. If you asked about the document DB, SQL, JavaScript, you can continue to use that. Or today we also announced that for tables customers who have been actually asking for secondary indexes, or we've been asking about, we want fast query, we want server-side programming, we want more consistency level, we want global distribution. They are globally replicated, but we want global distribution in terms of your data. You can interact with it. All you do is you take tables SDK, change the connection string, and you start talking to Cosmos DB, and it just works.
So quick question. So when you're actually setting up a Cosmos DB, you are deciding the kind of interaction that you're going to. You can't do hybrid interactions, for example.
So our vision is that at some point in time, we will actually allow complete hybrid interaction. You can do certain hybrid interactions today.
Sure.
One of the things that we've been working with our customers is trying to identify what are the scenarios where they would actually require this kind of hybrid interaction, and our vision is to actually enable that. This is similar to, we talked about the 5 consistency levels. Why did we choose these 5? Because we've been working with both internal first-party services as well as with external customers, and we see that a lot of databases talk about strong consistency and eventual consistency. It's only a very small fraction of the customers who actually want strong consistency in single digits, as well as very very small fraction of the customers who actually require eventual consistency, single digits. What we find is the three other consistency levels, the bounded staleness, session, and consistent prefix is the majority of what customers use. So based on your scenarios, you can actually choose. The way we will actually support multi-model of multiple APIs actually working with different models of data is going to be based on the same level of scenarios that we have.
Awesome. All right, so let's keep going. Sorry I interrupted.
So it's, I'm not, let me just show you, this is what it takes to actually create it. Let me take an instance of a database that I have.
Awesome, yeah, because it's better to have something with data in
correct,
it, right?
Yeah, let me pick up something like, the query demo one. And
is this showing you the replication, or what is
right?
This?
In this case, it's not replicated. So if I want to replicate this data to another data center, all I do is I go and select, click. Suddenly, Brazil South is a read region. Your data gets replicated across to Brazil
Holy
South.
Cow, that's amazing.
You can add as many as you want. I'm just not going to add it because I don't want to save this. Now, if I go back to my dashboard and pick up this query demo one, what I wanted to show is the richness of the data that we store. Doesn't cooperate.
There we go.
So if I just go to the Query Explorer, let's actually pick up, I do a demo with
So you have the so if I remember right, in CosmosDB you have things called collections.
So there's several types of containers.
Okay.
Collection is a container where we actually store documents.
Okay.
So in this case, it's actually a document. I'm using the document store.
Okay.
So in this case, there are collections. In this the collection I'm talking about. The database is earthquakes. There's an earthquake feed collection. I'm just going to run a basic query looking at what JSON documents are stored in there.
Okay.
What you see here is the JSON document that is returned. What I wanted to show is, like, if you're working with this is a good, cool application that actually looks at the number of earthquakes in a particular region.
Got it.
So this is storing geospatial data, and the polygon and the geospatial data can actually be stored in JSON. So we have full support for geospatial. A whole lot of mobile applications generally tend to look at how do they actually have images or media attached to it. So attachment support is a big one. They have, most of these applications are location aware or location sensitive.
Right.
So they want location information. That's also available in here.
And so when you're storing things, and you mentioned there's other things other than collections that you can store, but let's just say I'm storing something in a collection, I can store any kind of object graph.
That's correct, yeah. So we have a quick start. I don't know if I've available here. In one of the quick starts, if I go in here, so there are some quick starts in here. In one of the ones, if you actually create a new one using the Graph API, there are quick starts out here which gives you applications that you can download and interact with the entire graph model. And we actually demoed it at one of the sessions this morning.
That's awesome. So one of the things that when it comes to these kinds of databases or these kinds of data storage, I get confused about the shape of data that you store in it and how you should think about these things when you're storing. Because you said there's things other than collections. What are those, and when should I be using them?
So we calling them containers today.
Containers,
so
okay.
They're containers. So the way to think about this is, no data is actually born in the form of relational data in tables.
No,
and
it's
rows.
not.
You're just creating that, right? So think about how your application wants to interact with your data. If your application wants to interact with your data in the form of a key value, or if your application wants to interact with your data in terms of a graph with relationships and entities, you could store the data in that particular format. Behind the scene, we have a highly scalable storage engine that takes all of this, and we provide additional metadata to make sure this data is stored in the way that the application actually needs it.
Mm-hmm.
So containers are, where you keep these in the case of document, it's a collection. It could be a different container where you're actually storing graph data or key value state data or column family data.
So the next question I want to ask is, again, I'm so old school that you're going to help me fix this. When I wanted to store related data that was more graph-like structure, I would use the self-referential integrity kind of thing. It's obviously not like that when you do it in a container inside of CosmosDB. How do I store graph information in CosmosDB, and then how do I query it? So
the graph information that you're storing, you're actually not using referential integrity to store.
No.
Our graph engine actually knows, based on the query, our graph engine knows how to look at these different pieces of data and create it, right?
Got it.
From a query standpoint, we are all based on standards, which is Gremlin. If you are familiar with Gremlin language, use Gremlin to work with graphs, and we'll support the entire Gremlin framework.
So when I'm you're just saying, look, Seth, go look at Gremlin. It's all standard there. It'll teach you how to query stuff. Will it also teach me how to store stuff properly? Or is it just, if you select Gremlin, it's already in the format?
Correct. If you select Gremlin and if you're storing data using the Gremlin language, a graph engine knows how to break it down into the way it needs to be stored within the containers.
I see. Okay, that's amazing. So now the next question that I have for you is this. For those that are thinking about moving into something that's a container or a collection or document type store, what is some advice that you have for those that are moving over? And this might be a long sort of answer, and I'm okay with that because this, for some people, they're using, for example, MySQL, and they're finding that it's kind of bursting at the seams and things aren't really working, or maybe SQL Server isn't working for them, but they want to move to something that's globally consistent, et cetera. What are some advice that you have? What is some advice you have for them?
Yeah, I think the three pieces of design advices that I would have, or three pieces that you need to look at is, one is what is the partition key. Choosing the right partition key such that your data can be horizontally partitioned, such that your data grows as required and you can get the right amount of compute for each one of them. That's one key element of it. Second is understanding your workload, and in Azure CosmosDB, what you actually provision is provision throughput in the form of a request unit. Mm-hmm. So what does your request look like? We actually have a capacity planner or a request unit calculator, resource calculator. You can actually go give them a sample. Say in the case of a document, give a sample document and let us know, how many number of reads and number of writes per second, and actually say. So knowing that, so that you can provision at the right level. We also have what is called as provisioning at a minute granularity, so that you don't have to provision for your peak, even though your RU is provisioned at a seconds interval. Just in case if there is spiky workload, you can actually leverage that much RU during the particular minute. So understanding your workload pattern is the second one. So partition key, understanding your workload pattern, and third would be in terms of, look, where are your user bases? How do you really want your data to be replicated? Which are your read regions? Letting us know, we support multi-homing API, so letting us know that this is your write region, these are your read regions, such that in the case of a regional failover, we'll automatically fail you over to the next region as your write region. So that is the third aspect of design that you should be thinking.
And now when you're scaling out to different regions, are you automatically maintaining consistency?
Right. So consistency can be selected at a database level or a collection level in this case, or you could also set your consistency at the level of each of the read requests. So it's up to the developer in terms of what they want. Most cases, what we have seen is if they are looking at scenarios where you're interacting with a shopping cart, say maybe it's a session scenario, then you choose a consistency level like a session. So it's knowing the consistency level based on your application would actually help in terms of making the right trade-off between correctness of the data as well as whether it's availability or latency or throughput that you are actually trading off between.
That's awesome. So you mentioned three. One was partition, workload, and then where are your users. Let's talk about partitioning your data properly, because I have a hard time sometimes with this, and maybe you can give me like a real-world example of, look, here is the kind of thing you're storing, like customers. Now, this is how you should set up your partition key.
Yeah.
What would you suggest?
So in the case of, I'll actually say there are some good examples of thinking about how you, if you are looking at customers, say for example, and you are actually storing this customer information based on, say, a geographical information. So you could use a city name or some information like that, some metadata on it. If you're storing some information about some travel, it could be around points of interest or some airport code, etc. So it's basically, look, how do we actually make sure that you can evenly distribute this data set is important. The things that you need to be not concerned so much. The things you need to make sure that you're always aware of is like choosing a partition key like a date is probably not, or a day is probably not, because on a particular day you will find that particular partition, or a particular date that particular partition will be hard because you will be basically interacting with it. So it shouldn't be going to the extremes of where you are focusing on a small partition among the set of partitions. If you can actually think about what would actually evenly distribute a workload, that would be the right thing to choose.
That's awesome. So for those that are wanting to get started with CosmosDB, they're interested, they've learned about partitions, workloads, the users. What are some suggestions you have for them to get started? Obviously, you showed us a real easy demo. Is there some documentation that you already have?
Yeah, so a couple of things. I would actually, again, go back to my 3 point. One is it's super easy to get started in the portal. Our quick starts actually based on whether it's .NET, .NET Core, Xamarin, whichever model you're using, we have quick starts for each one of them. You can easily get it started. Each one of them is available in GitHub.
Right.
The other thing is Azure Cosmos DB actually has a full fidelity service emulator which you can download and use it on your desktop or your laptop and work with it. You don't have to worry about having an Azure connectivity. Work with it as if it's Azure. It also has its own quick starts that are embedded with it. You could download them and use with it. And the last piece of the information I have is like we have a lot of, we just updated our entire documentation. We have samples in there. They walk through the samples as well as they're connected to in terms of where they are stored in GitHub. So there's a rich amount of information. And if there's any questions beyond that, our email address is actually in most of these web pages. You can actually, in the documentation pages, you can directly connect with us too.
That's awesome. So we have about 4 minutes. You said something really fast at the beginning that I want to call out because it was really interesting. You said that Azure Cosmos DB is a foundational service in Azure. And when you said that, I was like, oh, that's interesting. And then I kind of went squirrel and started asking you another. Why don't you tell us what that means and then what implications that has for our customers?
Sure. So one of the things, I use the term foundational. I don't know if that is a real term.
No, you can use your own terms.
Or we say ring zero internally. Basically, every region that goes live will have Azure Cosmos DB by default. Where every government cloud, every sovereign cloud, every new region that comes online will have it. Which means if Azure customers, including Azure services, are taking a dependency on Azure Cosmos DB, they never need to be worried about whether it will be available in that particular region.
I see. So that means that anyone, anywhere, wherever there's an Azure wherever there's an Azure sort of cloud setup, Cosmos DB will be there.
Will be there, yeah. And you could span your one single database across all of these regions because we don't restrict in terms of the number of regions you can choose and associate with the database.
And it was cool because when you brought up the world, you literally started saying, okay, I want to replicate here, I want to replicate here.
That's why we call it turnkey. It's like just a click or in an SDK and your data starts getting replicated. You can start reading from your local regions using either region-specific APIs or, as I said, you could have a region-agnostic API that says that you can define where you want to fail over from one to the other.
So are there... when we talk about Azure Cosmos DB, what sort of things are being run in it already? You said that we are running some things on it already. Why don't you talk about that?
Yeah, so there are, I think at Scott Guthrie's keynote, we showcased a few customers that are actually using us. We have a lot of IoT scenarios that currently run on Azure Cosmos DB. Toyota actually, some of their use cases are currently run on Azure Cosmos DB. A lot of retail scenarios. We have several retail customers who are using Azure Cosmos DB for multitude of, whether it's event store, whether it is inventory management, whether it is for catalog management, gaming, a lot of mobile applications where you really need that low latency access, and you need customers don't want to wait for milliseconds to actually interact with the game or with an application. Those are all run. Internally, including the Azure portal, actually is backed up by Azure Cosmos DB. Azure portal uses it. IoT Suite, we have a lot of the IoT services that are leveraging. So I can go on and on. We have a lot of services that are
awesome.
Dependency on.
So a question from Sam, a bit confused about what Cosmos DB really is. There are multiple underlying database technologies, document DB, Azure Tables. Developer must still be making the decision as to where the data is stored. If that's the case, what exactly does Cosmos DB provide?
Oh, thanks for helping me clarify that. So if you think about this from a data standpoint or a database technology standpoint, there is just one, which is we have a database technology, which is both the storage engine as well as the query processing and the query engine that provides the capabilities I talked about, limitless scale, the throughput guarantees that I talked about, the low latency access, the multiple consistency levels, all of these backed by SLAs.
Cool.
Now, on top of that, what we are allowing is the way you store your data in the same engine, you can store in whichever model that the application really needs it, whether it is graph, whether it's column family, whether it is key value store or document. And then you as a developer can use whichever framework, whichever API you're familiar with, whether it's tables, MongoDB, Gremlin, and DocumentDB SQL.
Got it.
We will extend over the course of the next few months a lot more of the OSS APIs so that you can interact with Azure Cosmos DB from any language, any API of your choice.
I love it. This has been so informative. Thanks so much for spending some time with us. Thanks so much for watching. Coming up next, we're going to talk about Azure stuff.
Thank you.
With Corey Sanders, who, like the dude, does not answer my emails. I'm just saying. All right, so we'll see you right after this. Thanks for watching.
Thanks so much.